Hey, what's up, Bulldogs? Hello and welcome. I appreciate y'all being here. Let's get through this Mod 5 review, or the Mod 5 quiz, the final module quiz. We're going to get started with this worksheet, and I'm not going to be going through the notes. I am going to, however, be bringing up important concepts from the notes and incorporating them as we go along. So starting with number 1, here, 1A, B, and C, all require you to know that triangles, the addition of all the angles within a triangle, add up to 180 degrees. So this angle plus this angle plus this angle has to equal 180 degrees. 70 degrees plus 75 degrees plus whatever x is degrees has to equal 180. And we just have a quick little algebra problem to solve. 70 plus 75, 145 plus x equals 180. I combine those two like terms. I'm going to subtract 145 from both sides, and I'll be left with our answer. X is equal to 35 degrees. Sorry, x degrees is equal to 35. I suppose I should have put these degree symbols here too. No, that's not a zero exponent. That just denotes a degree. It's a degree symbol. All right, number 2. You can pause right here. If you need to finish copying, I'm moving on to number 2. Number 2, you add up these three angles. 2x plus 7x plus 3x. How many x's do we have all told? And remember, this has to equal, degree symbol, degree symbol, degree symbol, degree symbol. This all has to equal, when they add them up, they have to equal 180 degrees. All the angles within a triangle add up to 180 degrees. All right, divide both sides by 12. 180 divided by 12 is that 10, 15? All right. I'm going to erase and move on to number 3. Pause the video if you need to finish copying it down. Number 3, I'm going to leave up to you. And just a reminder, just a little hint, that square in the corner of a triangle means it's a right triangle, and that angle there is 90 degrees. That's your hint. We've gone through the first 3. Good luck on that third one. I guess we've gone through the first 2. Good luck on that third one. We're going to keep going. Before we do, if you're in class right now watching this video, feel free to share your exuberance for this geometry material with a or just a single bark. And I'll ask the sub, see if anyone barked randomly during the note-taking portion. Okay. Or during the video portion. Now we need to find, or use geometry and algebra to find the value of x. Once again, we know that the sum of these 3 angles has to be 180 degrees. Something else we know. We know that this straight angle here is going to be a total of 180 degrees. So if we just know what this is, what this angle here is, this one, we'll be able to figure out x, because this plus x will equal 180. All right, for starters, 62 plus 78 plus something. I'm going to call that something question mark for now. equals 180. Let's figure out what this angle is inside this triangle. So 62 plus 78, we've got 140 plus question mark equals 180. I know you guys can already see it, I bet. With the question mark in question, that angle inside that triangle is going to equal 40 degrees. All right. Last part, to figure out x, we need to set up another algebraic equation. 40 plus x equals 180. Because 40 plus x will equal this whole straight angle there. Subtract 40 from both sides. X is equal to 140. Whoops. X degrees is equal to 140. And if you get it backwards, in a quiz situation, I'm not going to take off points, but this is proper since they asked and defined x with a degree symbol. Sorry. I know you guys can pause the video, so go ahead and pause the video if you need to finish copying it. All right, moving on. Same concept as before here. I'm going to leave that one up to you, except instead of figuring out what this angle or that angle is, you have to figure out what that angle is. So that one's yours. Number 5 is yours. Number 6, I'll do with you, because number 6 is a tough one. All right. We know that whatever this angle is here, let's define it this time with a variable. Whatever this angle we're going to call y is, we know that 2x plus y plus 59 equals 180. And we know that y degrees plus 5x minus 4 equals 180. Now, we could set up a system of equations, and I'm tempted to do it, but due to time constraints, I'm actually not going to do that. To figure this out, I'm going to use the substitution property. I know that this thing right here, y plus 5x minus 4, equals 180. So, I also know that this thing up here, 2x plus y plus 59, also equals 180. So I'm going to replace the 180 with its other definition. I'll write it below. 2x plus y plus 59 is going to equal y plus 5x minus 4, since they're both equal to 180. So 2x, let me get a little thicker for this one. 2x plus y plus 59 equals y plus 5x minus 4. It looks complicated, but just remember, the only thing that we did just now was we plugged this thingy here in for 180, because we know it's equal to 180, and we can switch them out since they're equal to each other. That's all that we did. And now, because we did substitution, I'm going to subtract y from both sides. Boom, y goes away. I'm tempted to leave you guys to finish this problem, but I already left you number 5 in this section, so I'll finish it off up here. 2x, y is gone, plus 59 equals, y is gone, 5x minus 4. And now this is something I can do. Let me let me write a little bigger as well. All right, I'm going to subtract 5x from both sides. Combine my like terms. I could have subtracted 2x from both sides to combine my like terms, but I want to move my x this way, so figured I might as well do it first. So I subtract 5x from both sides first. I'm left with 2 minus 5, that's negative 3x, plus 59, equals negative 4. I'm going to subtract 59 from both sides. That'll leave me with negative 3x on my left. 59 goes away. Equals negative 4 minus 59. You owe me 4, then you owe me 59 more. Total of negative 63. One final step to get our x by itself. It's being multiplied by negative 3. Let us divide by negative 3, the opposite of multiplying. So that becomes 1. 1 times x is just x. But remember, what you do to one side of the equation, you must do to the other. Classic algebra. Right there. But negative 63 divided by negative 3, a negative divided by a negative is a positive. So it's going to be positive 63 divided by 3 is 21. All right, pause the video because I'm moving on. All right. The next concept that comes into play in this section is congruence. We've talked a little bit about it. It's the fancy word for equality, but we use congruence in geometry instead of equality. So for a congruence statement, they want triangle WPZ, boom, is congruent to, it's an equal sign with this squiggly thing on top, is congruent to triangle. Well, what's congruent to the W? The Q. What's congruent to the P? The V. And what's congruent to the Z? The S. I'll just take a moment now to point out a few things too about this drawing. Notice, this double shading here is intentional. It means that those two angles are congruent. Angle P and angle V, or those points, point P, point V, are congruent. And because this opposite side here is both of these opposite sides here are both part of a congruent triangle. As you can see, this side is also congruent to that side. And you can notice that is the case because of that little tick mark there. This side is congruent to this side. You can notice because of that double tick mark there. Okay, so let's finish this off. Point Z is congruent to point S. Point P is congruent to point V. Point Q is congruent to QW. And what about angle Z? Angle P, angle Q. I'll leave those up to you. Now I'll give you angle P. Sorry, I'll give you angle P is congruent to angle V. The little sideways V there is an angle symbol. So you guys finish this one. What is angle Q congruent to? And finish this one. What is angle Z congruent to? Easy enough, moving right along. I'm going to erase. Pause it if you need to copy. Awesome, doing good. Use the congruence relation, triangle LMN is congruent to triangle STR, to find the value of X and of ST. So they want us to find the value of X and of ST. Here's S, here's T, so they want the value of that segment length there. So inadvertently, we're also going to need to find Y. Man, this is an all-in-one problem. I kind of want to leave it to you guys. Maybe I will leave part of it to you guys. But I'm going to start it off for you, don't worry. Just to make it easier for myself, I'm going to make sure that I can tie all of these relationships together by labeling the final angle with 1, 2, 3. Okay. Now, I know what this one is, because 55 plus 65 is 120. 120 plus what equals 180? To those of you who said 60, well done. No, there's no audio delay. I'm just showing my work, and it takes a little longer than what happens in my head. But that's okay. It's just part of math. $60 degrees. All right, I know that that's 60 degrees, and I know that angle M is congruent to angle T. So 60, the measurement of angle M, is equal to 2x plus 30, the measurement of angle T. So since angle M congruent to angle T, therefore, that's what those 3 dots mean, therefore, 60 equals, or 2x plus 30 equals 60. So angle M is 60 equals angle T. All right, I'm going to go solve this equation real quick. I'm going to have 30 equals 2x. The opposite of multiplying by 2 is dividing by 2, so 15 equals x, or x equals 15. Since we like to have it with the variable on the left of an equation. Okay, we've solved for x. The value of x is 15. What about the value of st? Well, for that we need to figure out the value of y and then plug it in. I'm going to not erase because you guys can't erase. That's my x. Now let's use that somehow to figure out, oh, we don't have to use that at all. Instead, we can see that ST, angle 1 and angle 3, angle 1 to angle 3, so LM, are congruent as well. So I got to just rotate this. I don't need to rotate anything. I don't need to visualize this to know that from angle 1 to angle 3, or S to T, that's congruent to from angle 1 to angle 3, from L to M. Due to these congruence markers here, I know that these two segments are congruent as well. Meaning, I can set them equal to each other. Congruence is the fancy word for equality, right? So I can set these two equal to each other. So I'm going to set y plus 19 equal to 3y plus 5. From there, I am going to solve, do my algebra real quick. I'm going to combine my like terms. A y minus 3y is negative 2y. Subtract 19 from both sides. I'm going to have negative 2y equals negative 14. Divide both sides by negative 2. A negative divided by a negative is a positive. So we're going to have y equals 7. We're not done though. Remember, they wanted ST, or the measurement, or the magnitude, the length of ST. So let's plug in what we got for y, our 7, to finish this off. The measurement of segment ST is going to equal 3 times 7 plus 5. 3 times 7, 21 plus 5. 21 plus 5, 26. So the measurement of ST is 26, or if we want to be real proper, we can say ST equals 26. You can just circle the 26 though. I'll accept it. Okay guys, that was a big one. I know I said I'd stop partway through, but I didn't. I guess you're welcome. All right, I'm going to erase and move on. All right. For these questions, you're going to need to prove that some sort of isometry, which is a combination of translations, reflections, and or rotations, gets you from this figure here to this figure here, or from this figure here to this figure here. Let's prove it. And we're going to prove it using, let's see, in this case, the first thing that we're going to prove is, the first isometry that we're going to use is a translation. We're going to shift each of the points in this triangle a certain number to the right, so that's going to be x plus something, and a certain number up, so that's going to be y plus something. X plus how many? Well, let's look at point A to point P first. How many do we have to move A to the right before we move up so that it's going to replace point P here? Let's see, 1, 2, 3, 4, 5, 6, 7. So it'll be x plus 7. Sorry about that technical difficulty we briefly encountered there. Well, y'all briefly encountered it. Took me a little longer. But here we go, we're back. So we're going to shift this point 7 to the right, and then we're going to move it up 1, 2, 3, 4, 5, 6. Is it up 6? 1, 2, 3, 4, 6. Yep. Y plus 6. And if you notice, I'll do the same thing with this point here. I will move it 7 to the right, and then I'll move it 6 up, and here I am. Apologies again for that interruption. All that I was trying to show is that you can take any point, move it 7 to the right, and up 6, 7 to the right, and up 6, and that point will be translated correctly into the image from its pre-image. Okay, moving right along. For this next one, you are going to need a reflection. And I'm not going to give you the formula. You're welcome to pause this video and go look it up in your notes. But I am going to see if you guys can figure it out. So this point here is 0, 1. And this point here is 2, 3. For us to solve this without the formula is going to take a while. So I might go back on what I said and use the formula after all. 1, 2, 2, 4, 6. Okay, pause the video and see if you can find the pattern that gets these points reflected. It will require you to multiply by a negative, but your vectors will not be addition anymore or subtraction the way a translation would be. This is a reflection. So this reflection will require you to multiply by a negative. Yeah, I lied, my bad. I'm going to use the formula after all. It took me about 5 minutes to figure it out without it, so let's just use that formula for the sake of time. So what are we going to be reflecting over to get it flipped so that this sort of corner gets rotated around some line similar to this? If you remember, that line is y equals negative x. And if you are reflecting over y equals negative x, let me do it on the other side here. Your x comma y will become negative y comma negative x. So I'm going to erase some of the clutter here to try to visualize it for you to the best of my ability. Forgive my lack of drawing skills, but I hope this helps. So this is the line that we're reflecting this over. So when you reflect this, it's going to look sort of like, do it in red here. That'll go over here, that'll stay there. And then that'll go like here. So that'll be C naught, and that'll be A prime, sorry, C prime, A prime, and B prime right there. That would be our reflection. And then we have to also shift it. We're gonna have to shift it to the right and up. How many to the right and up? Sorry, to the right first, X first. 1, 2, 3. 1, 2, 3. So our final answer is going to be, let me do it in Bulldog purple. Negative y plus 3, that's your x value, ironically. And negative x plus 3, that's your y value. Go back to the notes if you want to understand more about the why behind that reflection. Okay, feel free to pause to finish copying or digesting. I'm moving on. All right, well, I'm going to do 11, 12, and 13 with you. I'll leave 14 for you, and the proof will be a little extra credit. Here we go. 11. Actually, before I go into 11, 12, and 13, here's another big chunk of information from this module, from Mod 6. In Mod 6, in Mod 5, we covered different postulates that allowed us to prove that two triangles were congruent or similar. So in this case, we're going to prove congruence using any of these following properties: side, 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 angle, side, angle, side, angle, 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 side. Those are different ways of proving that two triangles are congruent. So right off the bat, they gave us an easy one. We know that this side is congruent to this side, and this side with the 2 tick marks is congruent to that side. And we know that this side is congruent to this side with the 3 tick marks. Therefore, triangle ABC is congruent to triangle ABC DEF. DEF. Notice I'm going in the same order. A, B, C, D, E, F. And this is because of the side, side, side postulate. Because side, side, side. What about the next one? Well, we have these congruent angles. We have these congruent sides. Ooh, something else, vertical angles. We know that those 2 angles are congruent. Okay, I see it now. Angle, angle, side. Angle, angle, side. So, 2, 1 line, 2, 1 line. STR, triangle, STR is congruent to triangle STR. WD. S is double V. Triangle VTU. And why? Because angle, angle, side. Postulate. What about this last one? Okay. We know that this angle and this angle and this side, this side, this side, this side, this side. Is there an angle side side theorem? Or postulate? No. Yeah, there's not enough information for this one. Not enough info. There you go. Mod 5 review. Again, please tackle those notes, but I appreciate you, Bulldogs. I hope you enjoyed this review. Good luck on number 14. And yeah, take care.